Okay, containers. Now, containers is kind of a word like cloud computing, where it means it's a very short word for with a lot of different meanings, in my opinion. Basically, a container in Python's context is anything that holds multiple types or multiple things. Starting with lists, not to be confused with our lists. We'll talk a little bit about those. Tuples, we'll talk about those. Dictionaries, and we will not talk about sets because I do not know what a set is. But we will talk about lists, tuples, and dictionaries. And really the idea of containers becomes really important when you start programming with things like NumPy and ball arrays or zone arrays and that kind of thing. Okay, lists look like this. This is how you make a list. Lists are mutable, meaning you can add to the list. You can change a value in the list. Lists can have multiple types. They can be all integers. They can be floats and integers, strings and integers, all sorts of things. Python lists are extensive. There's hundreds of different things you can do to manipulate lists. Our lists were largely motivated by Python lists, mostly because they contain different types and they're mutable. But we do not have nearly the amount of methods or functions that Python lists have. So here we defined a list called data, 1, 2, 3, 4. Interesting enough, this would be, you would think, oh, I'm just gonna type print data. Print is like our, well, we'll get into that. Print is basically a way to see what your variable is, right? These two lines, print data, will give you an error. That's because this is old Python. This is like Python 2 point something. You need actually print and then brackets around it. Not square brackets, just regular brackets. So keep that in mind. And I have fixed that in a couple spots. So lists will have all these different functions associated with them. So they have things like length, basically it will return how many things are in that list. They got appending. You can loop on lists. Very nice. You can do fancy loops on lists for ID and enumerate. Enumerate is a way to loop through the list and then also give you a counter as you're looping. Very fancy way of looping. Indexing starts at 0, not the case for fish. To our embarrassment, the entire world uses indexing starts at 0. We use 1. Get really fancy with lists. You can basically go to the end of the list, return whatever is there. That's a nice party trick. You can take chunks of your list, chunks of data. See with this little colon operator. Yeah, and you can change. This has to do with mutability. You can change values in your list, remove stuff, delete stuff in your list, and that basically just skims the surface of lists. All right, tuples. They are very much like lists in every single way except one distinction. One very important distinction is that you cannot add to them. You cannot change values in tuples. Once you make the tuple, it is set as that. You can't add another variable. You can't change a variable. You're like, what the heck is it good for then, right? Most of the time we want a list and we want to do stuff to it. We want to change things in the list, or we want to split the list and do all these crazy things. Tuples are usually return values. So when you like return the displacement of a node in structural elements for FLAC2D, it returns a vector of X and Y. That's typically called a tuple in Python language. It's not something that you change. Dictionaries are a little fancier. They are a key value pair of any type. dictionaries have very fast lookup. So if you have a huge list of things, like in this case, we have a key that is a string called young, and its value pair is 1e⁻⁹. The nice thing about this is when you look up this, you don't need to, like, okay, loop through it all until I find something that says young and then return that value. No, this is like, you just give the key, here's the value. Fish has this exact same concept. They're called maps. They're very fast for looking up items and quickly. Okay, and then this is just a little more manipulation of the dictionary. And then this is, you can also iterate on the dictionary. So the idea whenever you see a dictionary is that it's always two values, key and value pair. Yes, you can delete things in them. Okay. Files and functions. This will be brief. This is how you define a function in Python, much like you define a function in Fish. This is how you do it in Python. The main thing you need to know concerning the syntax is that Python does not use, here's my function defined in brackets. Everything that's defined is always a tab right there. So so this line is defined, this line here is defined in the function. This line here is defined in the function. Why? Because it is tabbed 4 spaces to the right. This line is not defined in the function. It's calling the function, but mostly because it is not spaced 4 spaces or tabbed in, I should say. So it's all about the tabs when you're defining functions and what belongs in that function. Okay. So this is just to reiterate, you can pass arguments. Here's a little bit of output or writing to that, writing to a file. You'll see like a lot of these methods, these functions are predefined. They're just inherent to Python. Knowing what they are will require you probably to, going online and just say how to open a text file in Python. Oh, it's just the word open. Which these functions also will change depending on the version of Python that's being used. So that's something to keep in mind. Okay, we're not going to go through it and actually write and read from files, but just know you can do all of that in Python quite easily. All right, and now we're going to talk about the more advanced topic of NumPy arrays. NumPy is, like I said, it's a module built by someone else, not by ITASCA. And what it does is it takes arrays and it optimizes them so that they're very fast to multiply, add, split, do a lot of strange array operations, and it does it very quickly. You can build just a regular array or a list in Python that has the same data in it, but it won't operate or won't, loop through it or do things on it as nearly as quickly as NumPy can. Hence why that graphic I showed you why NumPy arrays are so fast. And whenever you're using NumPy, you'll always import it as NumPy. And very common, people just like to call it NP. So you can do things like this. You can load a text file. Say you have a bunch of data in a text file. You can load it. And this load txt is not something that's going to be in our documentation. If you want to find out more about these functions, you'll have to go online. NumPy has an entire website dedicated to just NumPy, and it will list all these different functions, all these fancy things you can do. So yeah. You can do, let's see, what are they doing here? They're just loading text, they're skipping rows, and they're taking a transpose. Anything .t is a transpose, and then print out X. You can multiply NumPy arrays. You can take arrays, X and Y here are actual NumPy's arrays, and then you can use them basically like they were numbers in an equation. The idea is that here the X NumPy array will be to the exponent of 2 will be squared. And then here, the NumPy array of Y will be multiplied by 19.23, and then all values in that array will be square rooted. And that's it for NumPy arrays. The point I want you to take away is that with NumPy arrays are a lot like when you guys were talking about lists and splitting. So instead of thinking of like, oh, I have a value of 1 or 2 here, what I actually have is an array of a bunch of numbers. And I'm going to operate on it much like I would a single number, but just remember that these operators, like the square here, is going to do it to each value in the list. And NumPy does it in such a way that every time you're doing these operations on the array, it's going to be faster than anything else. And it'll be faster than a list or a tuple. It'll be faster than a list and fish. It'll be faster than any of those. Okay, I think that is it for basic types. Really, NumPy arrays are not basic types, it's more of a way to make a basic type like an array faster.